In this video, we're continuing with Chapter 11. We're in Section 11.1 Part B. We're talking about similar polygons. So we just finished writing congruency statements for some angles and a proportionality statement for some sides. And what I wanted to note here is that in these ratios, we are comparing the measure of a side of the larger quadrilateral to the corresponding measure of a side of the smaller quadrilateral. So we have large side over small side for each of these proportions. It's important to know that we could have compared the measure of a side of the smaller quadrilateral to the corresponding measure of a side of the larger quadrilateral. So the point here is that the order is important in these proportional relationships, and you have to make sure that for each one of these ratios that the corresponding pieces are where they belong. So for this example, we had large over small is equal to large over to small is equal to large over to small. So keep that in mind when you're doing your proportionality statements, and make sure you get help if you need any help on that concept. Alright, so moving on to scale factor, let's talk about a definition first. So scale factor is the ratio of any two corresponding lengths in similar geometric figures. So if I have two similar geometric figures, triangles, quadrilaterals, doesn't matter what they are, as long as they're similar, if I take a ratio of one side to the length of one side to the length of the other side that it matches with and make a ratio out of that, we call that the scale factor. So scale factor is a ratio. Alright, so let's take a look at some similar polygons here. Remember, order matters, so we have to pay close attention to the questions. It says, what is the scale factor of triangle ABC to triangle DEF? So we could show that these are similar. We're just going to assume that they are right now. So what we need to do is pick a pair of matching sides. It doesn't really matter which ones you pick. So I'm going to pick this 8, and I can see that this 12 matches with it. So my scale factor, we'll call it SF, is going to be 8 over 12, and we always want to reduce our scale factor, so I'm going to divide each of these by 4 to get 2 over 3. So that's my scale factor of triangle ABC to triangle DEF. Now, for the next part, what is the scale factor of triangle DEF to triangle ABC? So in this case, the scale factor, so we could pick the same sides, but let's pick different sides. So let's pick 15 and 10. So now, triangle DEF, the side we picked is 15. The corresponding side on the smaller triangle is 10. And when I reduce this, I'll divide 15 by 5 to get 3. And 10 by 5 to get 2. So now we can see the scale factor is the reciprocal because we did the scale factor of the large to the small. Alright, and then the last part here, what is the ratio of the perimeter of triangle DEF to the perimeter of triangle ABC? So the perimeter of triangle DEF to the perimeter of triangle ABC. So DEF, its sides are 12 plus 15 plus 27, and ABC is 8 plus 10 plus 18. And if we add those all up, we get 54 over 36, and if we reduce that, we get 3 to 2. So notice that these are the same. So the ratio of the sides, the scale factor, is the same as the ratio of the perimeters. and that's something that we're going to use later. Alright, so similarity statements, remember the symbol for similar is this squiggle. Okay, a valid similarity statement must match corresponding angles and sides. So let's write a similarity statement for the triangles above. Again, it doesn't matter which way we write this, but it is important the way we write it if we're going to be writing scale factors. So we're going to do triangle ABC is similar to triangle DEF. Alright, so that's scale factor. If you have questions, make sure you get some help. If you need to rewatch anything, feel free, and we'll see you in the next video.